linear functions. Well, linear equation, remember before we talk about linear equation. So it will be equation of degree 1. Y equal to 1/2 x plus 3. That's a linear equation. Linear function, we just replace this y over here by f of x. Think about this f of x and y here can be interchanged. This is the function notation, okay? So f of x equal to 1/2 x plus 3. This is a linear function. Number 1, let's graph this linear function, f of x equal to 1/2 x plus 3. The way to graph this, you can first think about this f of x as y, so you can replace that by y. Y equal to this. Now this is in slope-intercept form. The y-intercept here is 3. So on the y-axis, we locate 3. The slope here is 1/2. So we're going to go up 1, start from 3 on the y-axis. We're going to go up 1 and run to the right side 2 to get another point. Now you can draw a straight line that goes through this 2 point. Then this is a graph for this linear function right here. So think about this f of x just as a y. Second, we're going to graph f of x equal to x. This is a linear function. So this is the same as y equal to 1x plus 0. Y equal to 1x plus 0. So the y-intercept here is 0. So on the y-axis, we locate 0. The slope here is 1. Now if you have an integer, why the integer is that integer over 1? So 1 is the same as 1 over 1. So the rise here is 1. So start from 0, we're going to go up 1. And then run here is positive 1. So run to the right side 1 unit here. Up 1, right 1 to get another point. Now draw the straight line here. This is the graph for this function, for this linear function, f of x equal to x. So this is the graph right here. Now, looking at the graph here, we can tell the domain and also the range. So the domain, remember, is a set of all possible x value, all possible inputs. So in this case, we look at what are the x coordinates for all those points on this graph right here. So this point takes on the x coordinate to be 0. This one takes on x coordinate to be 1. And actually, you see that if you take any point and you project to the x-axis, you see every number on this x-axis is a x coordinate for some point on the graph. So the domain over here will be every number, the domain. So every number on this x-axis, so every number on this x-axis is x coordinate for some points on this graph right here. Okay, so the way to find this domain is you can project from the point on the graph right here, project to this x-axis, and try to find out what kind of x coordinate they take. It looks like it takes on every number on this x-axis. So the domain here will be all real number. So you can put an R with double bar. What about the range? The range is the set of all possible y values, or think about here as y coordinate. So let's find out what kind of y coordinate does this do those points on this graph right here take. So you project to this y-axis. So you draw from every, so you're going to take those points on the graph right here, and you draw horizontal line to project that to the y-axis. You see that every number on this y-axis is a possible y coordinate for some point on the graph. So the range over here is going to be all real number again. Number 3, f of x equal to 2, which is the same as y equal to 2. The graph of this is a horizontal line passing 2 on this y-axis. So the domain for this, well, let's project this down to this x-axis. You see every point on this x-axis got projected. So the domain will be all real number. So any number on this x-axis is a possible x-coordinate of some point on this graph right here. What about the range? The range over here will be, well, let's see what kind of y-coordinate those points on this graph right here take. Well, looks like that they only take on this y value 2 and nothing else. So the range over here will be the set. Okay, remember this, a pair of curly braces is the set notation. So it's a set that contains only 2 in it. So you put a 2 inside this set right here. Okay, so this is the answer here for the range. It's a set that has only one element, which is 2.